Let's go. Let's do this. Terminal. And here you can pull this, or you can just pull master. That's totally fine. But I'm gonna just use task 10. And task 10, if I'm not mistaken, might be using the latest Bitcoin dev kit. Nope, we're still on 0.2.1 dev. So at least that's good for consistency. We're not using a different library because the master will be using the 0.3.0 master branch, I mean. Okay. This last part is about enabling wallet recovery. We want to give the option to the user of pulling their 12-word recovery phrase and then just like inputting that into the device, and the device being able to recover the wallet from that. It's not a very complicated task, and you should practice it on the Bitcoin CLI if you have a chance. And we're going to have a look at the wallet to see how that's done. So again, this is my wallet class, and what we want to do is use the method called recover wallet. And the recover wallet method will require a string, the mnemonic string, right? So this is a string of 12 words. In this case, it's hard-coded, so I'm just using 12. That's another thing. I should write this down as an option. You could possibly implement that as an addition to the wallet. Some people want to maybe use more like 24 words. Usually that's also a very common use of the words, is either 12 or 24, the two big ones. And so right now the user doesn't have that option. It's hard coded. We're just using 12 words because I want to make it simple. But a lot of people will use 24 words, or are used to 24 words, or they might have a wallet that's coming from somewhere else that was generated using 24 words, right? So if they used a software else that was generating wallets using 24 words, then they wouldn't be able to implement to recover using our Sobi wallet right now. So an option for the user could be, when they get going, could be, do you want a 24-word wallet or a 12-word wallet? It's definitely something you could implement, and we have everything we need here in this app right now to do it. You just need to refactor some of the things. So this recovery wallet, we give it a mnemonic, and once it has a mnemonic, then it's super easy. We just basically call the restore extended key from mnemonic. And this is what it is. Again, it takes a mnemonic and it returns an extended key. So, and we're calling the lib restore extended key, and that's it. So the complexity is really not on the BDK side of things in this case. The hard part is to say, how do you come up with that mnemonic, right? Where is that mnemonic? How does it get passed around? So I'm going to show you what it looks like in the layout. Fragment recover. Okay. So this is it. It's basically a scroll. You can scroll through these 12 words, and that's it. Easy as pie. I'm just gonna I'm gonna format this whole clean up this guy, wipe the data on it. Oh, I was using the Pixel 3, I think. Okay. Need to exit this. Okay. So wipe it clean. Okay. So we're going to fire this up. And notice that what's going to happen is that when we fire this up, our shared preferences are going to say, I don't have well, this is, Okay, yeah, it's waiting for the emulator to come online. The shared preferences, the default for whether a wallet's been initialized is false. So when the app starts, we go to our dispatch, and our dispatch activity will ask the repository class, hey, do you have any wallet on the device? And the repository will respond by saying, I don't. And because it doesn't have anything, it will launch into the wallet choice fragment activity, sorry. And this is what's happening here. This is the wallet choice, right? If you remember. And now we can create a wallet or recover an existing wallet. And I want to show you the UI for the recover the existing wallet. So at this point, we don't have the Bitcoin Dev Kit library loaded. We just have our words. Oh, I just wiped the data with the testnet coins that I had. So it's too bad. Those coins are not lost because the seed phrase, I showed it on the thing, and because this is being recorded, somebody will be able to go back in the recording and pull those coins back out using this recovery function, right? But at the moment, I don't actually know what it was, so won't be able to recover my wallet. But yeah, so this is how it would work. We would just input our words. So, you know, test and then gas or whatever. And I'll show you how it works. When you've inputted your word, if you press the recover, if you have a word that's empty or invalid, it will it'll fire up a snack bar, an error snack bar. So in this case, it's saying that this particular word is empty, and we might, you know, let's say I put a there's a typo in one of my words. I could try to recover, and it'll tell me that the word number 3 is invalid. So we have two types of snack bars here. There's a test for whether the words are valid, and then there's a test for there's a test for whether the word is empty. And if it's not empty, then there's a test for whether the word is valid or not. And then if they are valid and they're there and they're valid, then we just move on. And if we have all 12 of them, we basically collect those 12, concatenate them into a single string, and that's our mnemonic, and we can just feed it to the Bitcoin wallet class. So let's take a quick look at this. Actually, our recover fragment. If you look at the recover fragment, it's just a code. You'll find just a bunch of text views inside this linear layout. So word 1, word 2, right? They all have an ID. Word 1, word 2, word 3, and they're all edit text. So we can go in and fix them up. We can, input things. So it's just 12 of the 12 of those, excuse me, and we're gonna go and use them basically. So let's have a look at the recover wallet fragment. So this recover wallet fragment is quite long. I think it's our longest file, so 116 lines, 117, and but what it does is fairly simple. So we are creating a list of words. The first thing we want to do is have this list of words, right? I don't want to get into all the BIP39 recovery phrase thing, because I think you might have seen it 2 weeks ago. So I don't want to repeat too much, but it is that list of words is inside my my resources. Dun, dun. So if you look under assets here, BIP39 English, that's something else you could work on for the rest of the week if you wanted. You could try to implement this, but with a different word list, and offer that as an option to the user, because these word lists are, they exist in many different languages. So one could decide to do it in other languages, including like, yeah, just like I think it's like 6, 8, 10. There's quite a few, so it's kind of cool. And it's a list of 2,048 words. Last one is zoo, and the first one is abandon. Yeah, that's right. And so we load this list of 2,048 words into memory, and we have it ready to go to test against the words that are provided by the user. And so the big all the work is happening here in this recover wallet button. So we set an on-click listener, and it has to go through two different things. Basically, it has to go through this one method called check words, and if it passes, right, this check words, if you look at the function signature, the method signature here, it returns a Boolean. So this check words method will basically finish with a true or false. And that's all it is. So if it returns with a true here, we're going to flow into that part of the if statement. And we're creating this recovery phrase string using the bill recovery phrase method. It's at the bottom here. It's pretty simple. We're just basically going through all the views, picking them, and just concatenating all of that into one. So notice I'm like trimming the ends if there's spaces, and I'm bringing them into lowercase. So you could even write it with capitals, no capitals, all of that. It will just get cleaned up, and we provide it with as a list of like there's one space separating each of the word. So it's super simple. So that's what this build recovery phrase method is doing. It returns a string. So that's if it works. And then if it works, that means that we can fire up line 50, which calls the recover wallet method on the wallet class. So, and that will communicate again with the BDK, and it'll just like create a wallet for you. And once that's being done, again, we're setting the mnemonic in the repository, the shared preferences, right? So now we're like loading that stuff in memory. We're making sure it'll be there for the next time. We're turning the Boolean initialized, the shared preferences initialized Boolean to true. So the next time the user fires up the wallet, that dispatch activity will see that the wallet is already on the user's device, and so it won't send you down the activity path of like the wallet choice. It'll send you directly to the wallet. So that's sort of what's happening here. But really what matters, or what the most complicated part, is the check words method. And this check words method is here, returns a Boolean. And what we're doing is pulling each of those, right? I have this loop here, this for loop for each of the words in 0 to 11, because I've created this list. Mnemonic words text views. Anyway, I've created this list, and I basically pull from it the word, the text. I trim it, I lowercase it, and then logging it. So we're saying like, here's the verification, and here's the word and the mnemonic. And then we have this when statement. They're sort of like switch statements for Kotlin, the when statements. And so if it's empty, then we just fire up a snack bar with the error that the word is empty, and we return false. And if it's if the word is not in the list, we do the same thing, is empty or is invalid, whatever. And if not, then we just keep going through the loop. And if the loop has gone through the whole loop without throwing a false, returning a false, then we just return true. And when it does that, it basically keeps going there. So we build the wallet, and we fire it up. How is that? I know that one of the comments from yesterday was that I was going a bit fast. Many of the comments from yesterday was that I was going a bit fast. So I want to really slow down, give you time to try that stuff, see the log cats for yourself, fix it up, fire some questions you have in the chat. I know it's a big group, so like people are not really asking questions. So that's been the what's happening is I just like keep going, but we're going super fast, I know. Okay, so one of the people who, if you have coins on your wallet right now, it's like some of the folks who were sending each other coins. If you have coins on your wallet, please post, copy paste your 12-word recovery phrase for me in the chat. And if you do that, I'm going to try to recover your wallet right from here. Thank you, sir. Here we go. I'm going to try to recover this wallet. Let's look at the logcat. Okay. So we're going to do this palace. Spend enable alien and alien. And here, notice I have a typo, right? And it should throw. Oh. Sorry. I'm not sure what happened there. I wanted to test the snack bar, but we're going to try to move along here and just put in the right word. Spend. Okay, let's see. If this crashes, then... Ah, okay, so good. And now if I look at my transaction history, there's nothing. The wallet doesn't know about anything yet. But if I sync, nice. And that's it. Ladies and gentlemen, this is the gist of our wallet. Everything works. It's pretty neat. It's got all the basics, right? It's got all the basics to maybe give you something to build on. So I'm hoping that this is a good place for you to ask questions, because we're sort of getting there in terms of like what I wanted to show. And the last part maybe is I'll show you the master branch, and we'll have a look at the latest commits on it to see a little bit what are the latest things that I did on it. There's not that much, but okay. Let me just I'm gonna roll back this. Okay. Okay. Wallet recovery. Okay, so this is it. We're at the end of the web page. And so I will go into the BDK, no, sorry, Summer Bitcoin wallet. And we're going to look at the commits. So you folks are looking probably at, yeah, something like this here, this commit, sort transaction. Oh, not even. Wow, nice. Yeah. We've made quite a few changes here. Maybe I'll build. We'll see. One of the things, one of the big changes is the arrival of the 0.3.0 BDK. And I'm going to recover the wallet we had there, just so we can get going immediately. Fun. Sync. And if I look at transaction history, I find we have 4 transactions, and I've split them into confirm and pending transactions. Sorry. So we've got no pending transactions and a bunch 4 different confirmed transactions. And this is happening because with the 0.3.0 version of Bitcoin Dev Kit, we're going to go and have a look at that, the transactions fragment. I might need to resync my Gradle files, but we are receiving this list of transactions, and now I'm using a few neat sort of like Kotlin standard library methods to clean that up and sort them by descending. And in some cases, this confirmation time type will be null. And when it is, I'm going to give it a confirmation time of 100 million. So the height, the block will be 100 million. And then when I sort the transactions based on that, no, sorry, here we're using a filter for null. So if the confirmation time is null, we're going to go and put a string here on the timestamp. It'll say pending, and it'll show up in this pending category. And if not, it'll show up in the confirmed category. So this is where this is happening here in this whole thing. And instead of building this line, this string that I concatenate, I'm using a Kotlin standard library function called build string, where you can use loops in there. It's like you give it a lambda, super neat. And so here I can loop over things and then append lines, so it's easier to read. So immediately the eye, when you're looking at this, the eye can catch what we're trying to do. And the harder one of those, the one that gets the most transformation, is this one, the confirmation time. And we're applying this timestamp to string method to it, which is an extension method I've defined in my timestamps here. If you're not familiar with extension functions in Kotlin, they're like super, super neat things where you can have types that are defined and are defined completely out of your control by other libraries or even by the standard library, say the int type or the string type, and you can add methods to them by defining them and using them. They're called receivers here. And you can define new methods on them as if they were defined inside the class. So it's super neat from the user's perspective. Like on the call site, they look like they were defined as part of the class forever. There's nothing different about them, but they're actually defined by you. And so they're defined in these other files. So it allows you to extend other people's code in a way that on the call site, it looks really neat, and it doesn't show as anything different. So you're not calling these weird functions like timestamp to string, where like you need to give it whatever type you're trying to use, and then you modify that type and return it. You're literally modifying this confirmation time type just on the go, and on the call site, it looks like this method was always defined on it. So you can do really neat stuff on it, and that's what I'm doing here. So the confirmation time type is defined in BDK JNI. So this is not under my control. I can't do anything about it. Other than that, I'm a contributor to the library. But here, what I'm saying is I'm going to extend that type, and I'm going to give it an extra method that I want to define on it. I'm going to call it timestamp to string. And this is what basically it does. And from there, in the transaction fragments, I'm calling it on the type, on the variable, as if it had always been defined for it. So it's pretty neat. So that's what we're doing. building this transaction and then, displaying them. If it's pending, we go in this other list, and then we, I just change, I write pending instead, that kind of stuff. Human readable timestamp. And that's defined in version 0.3.0. Fix some margins, tags, sort the transaction in history view. Yep. This commit here split this transaction history into these two parts, the pending and the confirmed. Some UI fixes, and then Benro was actually the first contributor to the library who proposed a new use of this shared pref manager class. Take some time to have a look at it. It's kind of like a neat way to deal with the shared preferences, a very Kotlin-ish way to deal with it. So it's simply a class that has a bunch of variables on it, and we can set them and query them super easily. And so when we've defined this class, it's a bit messy in here, right? But now if you look at my repository, we've cleaned up my repository real good. It looks really clean on the call site. So if you look at, for example, my line 34, shared preferences manager dot wallet initialized equal true, and then path and descriptor. Save mnemonic, or like get mnemonic, we're just, look at that line. This is just like real neat. Shared preferences manager dot mnemonic. We just return it. So that's what this this shared preference manager class created. Hopefully that's and those are just like, we're adding a bit of like simplicity for the user to read, but they don't change like the fundamentals of what the app is doing. And that's sort of it. That's what we're doing for this app, and that's what happens if you pull on the master. And that's it.